Today, we're taking a closer look at MinuteEarth. The channel has over 3.2 million subscribers and nearly 600 million views. It focuses on short videos that explain science topics related to biology, animals, and the natural world. On February 5th, 2026, MinuteEarth uploaded a video titled 40 Years Without a New Antibiotic. Why? The video aims to explain why supposedly no new types of antibiotics have been discovered in the past 40 years.
Early on, this approach kept turning up new types of antibiotics, but in the 1970s, these discoveries stopped. Instead, researchers just kept finding new variations of the same old types of antibiotics that they already knew about. Because of this discovery drought, doctors haven't been able to prescribe a new type of antibiotic in nearly 40 years.
Now this is just plain wrong. Discovery of antibiotics has not stopped in the 1970s. The antibiotics discovered after the 70s may not have been as impactful or widely used as penicillin and co., but they still, to this day, play an important role in treating serious infections that are resistant to more commonly prescribed antibiotics. Here's one example. Daptomycin, an antibiotic from the novel group of cyclic lipopeptides. It was first discovered in 1986 and was only approved as a medication in 2003. Daptomycin binds to the bacterial cell membrane and disrupts it, which quickly kills susceptible bacteria. It's very effective and mainly used for serious gram-positive infections, including complicated skin, soft tissue infections, and Staphylococcus aureus bloodstream infections.
Now, the problem had to do with their basic discovery process. You see, growing microbes in a lab is a lot like breeding animals in a zoo. Some animals, and some microbes, they multiply and thrive just fine in human-made confines. But most microbes are like pandas, which are notoriously difficult to keep happy in captivity. So scientists are switching up their search strategies. They're going back to looking for microbes in the wild, but this time with fancier tools that don't require breeding them in petri zoos. For example, some new devices allow researchers to grow and observe bacteria in their natural environments. In these days, researchers don't even have to grow microbes to see what they're capable of. They can simply sift through their DNA to identify potential antibiotic-making genes. Scientists are also looking for microbes in places other than soil, like in the ocean, which is full of unknown and potentially useful microbial life. And these methods might be starting to pay off. In 2025, a group of scientists identified a completely new type of antibiotic, which just so happens to be shaped like a little molecular lasso.
Okay, where should I even start here? Maybe with the fact that the name of the antibiotic mentioned on the pedestal is wrong. They wrote polymycin, which by the way was already discovered in 1947. But what they are actually talking about is Lariocidin, a completely different molecule. Now, how do you think this was discovered? Maybe with special devices that scientists plugged into the ground? Maybe in the ocean? Or maybe they just looked at the DNA? Far from it. Here's what was mentioned in the original paper, link in the description. Scientists cultivated soil samples on nutrient-poor agar, which is a growth medium for bacteria, and incubated them at room temperature for nearly a year. This long incubation allowed slow-growing, normally overlooked bacteria to form colonies. Researchers then prepared extracts from the grown strains and screened them for antibacterial activity. One extract showed strong activity and was traced back to a previously uncharacterized bacterium, which was identified as a Panibacillus species. So while new methods are surely developed and in use, all of this lengthy explanation of how these new methods allowed for the discovery of new drugs had nothing to do with how this example of a new antibiotic was actually discovered. Instead, it just serves as an inspiring and exciting story that has nothing to do with the incremental and messy reality of science. In addition, this is just the beginning for this new class of antibiotic. For any novel type of medication, it can take decades until it is approved by the FDA, and many of them fail their clinical trials. For example, because they are too toxic for humans. Discovery of new antibiotic candidates are made all the time. What's rare is not finding a new antibacterial compound, it's finding one that ultimately survives the long path to clinical approval. I hope this encouraged you to be a bit more careful when trusting educational YouTube videos and to do some research yourself. If you come across a video that contains misinformation, misconceptions, or just doesn't seem right, feel free to email me or let me know in the comments. Maybe I'll make a video about it. If you'd like to help me reduce the impact of misinformation on YouTube, consider leaving a like, subscribing, or supporting me on Patreon.